$2.5 billion is the annual financial toll caused by feral pigs across the United States. However, in Australia, the yellow crazy ant has wreaked havoc on a significantly greater scale. In just a few years, these insects established a super colony of 12 billion individuals, 50 times the country's population. But this is just the beginning. One can notice how the forest floor falls silent as red crabs vanish. Why did the ecological balance crumble so rapidly? The loss of 40 million red crabs was only the surface of the disaster. This event triggered the collapse of an ecosystem that had existed for over 100 million years. At first glance, it seems that stopping such a force requires chemicals, but in reality, the reversal of this crisis came from a creature so tiny you could miss it in the blink of an eye. The parasitic wasp became the unexpected savior. Its introduction changed the dynamic of the infestation entirely. It gets more complex further on. It is visible how the insect intervenes in the process to turn the tide. This stands as the strangest biological battle in Australian history. The parasitic wasp proved to be the key to saving an entire ecosystem on the brink of collapse. The natural world slowly begins its restoration. 200 million red crabs dominate a remote landmass inhabited by only 1,800 humans. This staggering ratio results in over 110,000 crustaceans for every single person living on the terrain. Located in the Indian Ocean and governed as an Australian territory, the location functions primarily as the kingdom of red crabs. But this is just the beginning. Have you ever wondered why the map officially labels this place Christmas Island? The answer dates back to the year 1643, although the connection is strictly based on the calendar. A British sea captain stumbled upon the isolated landmass exactly on Christmas Day. At first glance, the island appears to be a pristine sanctuary, but in reality, permanent settlement only began over 200 years later for industrial extraction. Miners arrived to harvest phosphate, a mineral formed from bird droppings that nourished the nutrient-rich soil. For 37 million years of isolation, the red crabs have evolved into the region's ecosystem engineers. One can notice how they tirelessly dig through the soil to maintain the rainforest's flawless rhythm. Every year, the world turns its attention to this specific coordinate to witness a breathtaking biological phenomenon. Hundreds of millions of red crabs emerge simultaneously from the dense forest cover. It is visible how they flood the terrain, crossing paved roads and climbing specially constructed crab bridges. They descend in a massive living wave toward the sea to spawn. The process is only gaining momentum. This spectacle is so iconic that Google once dedicated a doodle to the event, marking its global significance. Because of this biodiversity, more than 70% of the land is strictly protected as a national park. The sanctuary safeguards a nearly untouched ecosystem containing underground rivers and rare endemic species. Giant coconut crabs and Abbott's booby birds coexist alongside the massive red crab population. These crustaceans serve as the foundation holding the biological structure together. When the crabs live, the forest breathes, but if they vanish, the system begins to collapse. The ecosystem continues its cycle, relying on the millions of creatures moving across the floor. 12 billion. That is the staggering number of individual invaders that once occupied the island, outnumbering the human population of Australia 50 times over. At first glance, the island's ecological balance seemed unshakable, but in reality, cargo ships brought a threat far deadlier than any predator the red crabs had ever faced. The yellow crazy ant quietly arrived alongside imported goods sometime in the 20th century, slipping past inspections almost completely unnoticed. This silent introduction marked the start of a shift that would dismantle an ecosystem millions of years in the making. Why was this specific species named crazy by researchers? It has nothing to do with biological madness. The name comes from their erratic, frantic movements and an incredibly fast attack speed that defies the eye. Without natural land-based predators to check their expansion, these ants turned the island into a defenseless paradise for their own kind. They began forming massive super colonies where billions of individuals functioned as a single, terrifyingly unified organism. During the rainy season, one can notice how the yellow crazy ants surge to the surface like a living acid flow, flooding the forest floor. But this is just the beginning of the devastation. The invaders march straight into red crab territory armed with formic acid, one of the strongest naturally occurring acids known to science. It is visible how the ants spray this caustic substance directly into the crab's eyes, blinding the large crustaceans within mere seconds. Thousands of tiny attackers then swarm the incapacitated giants, overwhelming their defenses and killing them in less than 24 hours. Scientists have described these scenes as a natural chemical war, where millimeter-sized creatures wield biological weapons to bring down animals hundreds of times their own size. The process is only gaining momentum as the death toll rises. The results were immediate and catastrophic, causing the red crab population to plummet from 40 million down to as low as 15 million. Because the forest lost its army of leaf-clearing workers, thick layers of decaying organic matter piled up, suffocating the soil. The rainforest floor became drier and significantly more prone to fires, while the ground grew oxygen-deprived. Young trees sprouted uncontrollably, choking the understory and forcing endemic birds like Abbott's booby to abandon their nesting grounds as mature trees began dying in large numbers. An ecosystem that had operated in perfect harmony for 110 million years began to crack apart, all within the span of just a few rainy seasons. 95% is the staggering increase in yellow crazy ant density recorded in areas inhabited by their silent partner. Why did this specific invasive species conquer the Christmas Island ecosystem so rapidly compared to other pests? The answer isn't found solely in the ants' own biology or their aggressive nature. It lies in a strange natural alliance with the yellow lac-scale insect. This tiny creature became the key that allowed the ants to multiply at a rate beyond anything scientists had previously observed in standard ecological models. But this is just the beginning of the invasion mechanics. Yellow lac scales cling tightly to the rough bark of tree trunks, piercing the surface to feed on the vital sap within. One can notice how these immobile insects excrete a sweet substance known as honeydew in small droplets while feeding. To the yellow crazy ants, this fluid acts like high-energy fuel, providing a constant food source that enables them to reproduce rapidly. At first glance, it seems like a simple exchange of nutrients, but in reality, it powers a non-stop cycle of activity. Because the ants receive this unlimited supply, they protect the scales like livestock in a sophisticated form of insect agriculture. One can observe them chasing off or killing every natural predator that attempts to approach the scale insects. This protection causes the scale population to surge uncontrollably across the island's vegetation. And this is not the limit of the destruction. As the number of scales grows, so does the volume of honeydew produced. Therefore, this feedback loop fuels an even greater explosion in the ant population, a phenomenon scientists liken to pouring gasoline on a fire. But unlike in their native ranges, yellow crazy ants face virtually no biological resistance on Christmas Island. There are no birds to eat them, nor reptiles in high enough numbers to keep the swarm in check. With no natural enemies to slow their reproduction, they turn every square meter of forest into part of a vast supercolony. One can visualize the yellow tide spreading centimeter by centimeter each day. The entire ecosystem is slowly engulfed by this expanding empire of ants. 6 pounds per acre is the precise density at which helicopters rain down death upon the rainforest canopy. Faced with the explosive spread of yellow crazy ants, humans were forced to intervene with extreme measures. For many years, the singular solution available to Australia was a protein bait laced with fipronil, a highly potent chemical capable of wiping out entire ant colonies from just a few individuals consuming it. But this is just the beginning of the logistical struggle. Why was the timing of this bombardment calculated down to the day? At first glance, it seems the bait could be deployed at any moment to stop the invasion. But in reality, the operation was restricted strictly to the dry season, when red crabs remained hidden in their burrows. If the schedule slipped by even a few weeks, millions of crabs would emerge for migration and accidentally consume the toxic pellets. A single calculation error could turn a conservation campaign into a second ecological disaster. Helicopters navigate rugged terrain to deliver the payload. One can notice how the aircraft maneuver dangerously close to the canopy over cliffs, dense rainforests, and deep valleys to ensure coverage. They drop the bait at a strictly controlled density, and at one point, it seemed like victory was within reach. Within just 4 weeks, ant numbers had dropped by 99%. It gets more complex further on. the relief proved to be deceptively short-lived. From untreated corners of the forest, the yellow crazy ants re-emerged, stronger and more numerous. It is visible how the supercolony surges back, seemingly immune to the previous chemical bombardment. Using fipronil turned out to be like mowing weeds without ever pulling out the roots. But the visual cleanliness of the forest floor was deceptive. Underground, the supercolony continued to silently regenerate. Worse still, fipronil did not discriminate between friend and foe. One can observe how the poison eliminates native insects alongside the ants, disrupting ancient food chains. Conservationists were left with a troubling question. Are we saving the ecosystem by destroying it? And this is not the limit of the complications. Each large-scale campaign could cost between $1,300,000 and $2 million, not including manpower, equipment, and the risks involved. All of this pointed to a sobering truth. Chemicals could simply not be the long-term answer for this battle. 131 native species underwent rigorous testing for over 3 years before a single decision was made. When standard chemical options reached a dead end, Australia was forced to pursue an entirely new solution. Why risk introducing another insect into the ecosystem after the lessons of the past? The memory of the 1935 cane toad disaster still plagued the continent with nearly a century of ecological consequences. To prevent another biological catastrophe, scientists had to ensure the new agent would ignore everything except its specific target. But the real objective was never the ants themselves. One can notice that the yellow lac scale serves as the living fuel factory powering the entire yellow crazy ant empire. These stationary insects produce the sugary honeydew that the supercolonies rely on for their relentless expansion. Severing this supply line required a creature of microscopic proportions to infiltrate the system. The parasitic wasp, Tachardiophagus somervillei, became the chosen solution for this precision strike. This creature is so tiny that it could easily fit on the head of a pin. At first glance, releasing such a small insect seems insignificant, but in reality, each wasp acts as a highly effective biological agent. It seeks out the yellow lac scales, pierces their bodies, and lays its eggs deep inside the host. And this is not the limit of the process. Destruction comes from the inside as the wasp larvae hatch and begin to consume the scale insect. Helicopters took flight over the hot zones once all risks had been assessed and minimized to the absolute limit. The doors opened to release 18,000 parasitic wasps into the open air. It is visible how the silent army disperses into the treetops, drifting quietly without the roar of machinery or the use of toxic bait. Eventually, only a hollow shell remains where the productive scale insect once lived. The supply of honeydew runs dry, and the ants lose the essential fuel they need to continue. Thus, the tiny creatures complete their mission to dismantle the energy supply of the invasive empire. 700 ants per square meter, exactly the suffocating density recorded at the absolute peak of the infestation. In the first few months after the parasitic wasps were released, no one dared to hope for a radical shift. The introduced wasps were microscopic in size, while the scale insects coated nearly every branch, and the yellow crazy ants still dominated the forest canopy. At first glance, the strategy seemed unequal, but in reality, the invisible war had already begun to shift the balance. Why did the impregnable ant empire begin to crumble so rapidly? The collapse did not happen instantly or chaotically. The answer lies in the specific target of the biological control. The wasps attacked the yellow lac scales, cutting off the supply of sticky honeydew. Without this sugar-rich fuel to sustain their hyperactive metabolism, the supercolonies began to starve and weaken. The spread of the invaders slowed significantly as their energy reserves depleted. Ant densities dropped sharply in the treated sectors, creating pockets of silence where there was once frantic movement. 2 years after helicopters opened their doors to unleash the airborne army, scientists returned to the primary hotspot to verify the data. What they saw left the entire team stunned. In a place that once recorded 700 ants per square meter, only slightly more than 10 ants remained alive. The empire lay in ruins. But this is just the beginning. The island's true residents began to emerge from their hiding spots to reclaim the territory. One can notice how red crabs, once decimated by the tens of millions, appeared again along the forest trails. They tirelessly dug new burrows and cleared the thick layers of leaf litter, reactivating the ecosystem like a machine being oiled after years of paralysis. The number of red crabs participating in the migration surged from 40 to 50 million up to over 100 million by the year 2024. Forest patches once blanketed in black mold started to turn vibrant green again, and endemic bird species like Abbott's boobies finally stopped their decline. However, the story is far from over. Danger still lurks in the deep forest zones where humans have never set foot. Yellow crazy ants have not disappeared entirely. They have simply retreated into these untreated shadows. In these remote pockets, yellow laxscales still survive, providing enough honeydew to sustain the remnants of the supercolonies. It gets more complex further on. During the rainy season, billions of ants can rise again from the soil. A single misstep in management could trigger a resurgence, allowing them to spread back into controlled zones. This would enable them to rebuild their empire faster than anyone might expect. Therefore, the ecosystem remains in a delicate state of recovery. The story on Christmas Island is a powerful reminder that complex networks sustained over millions of years can be shattered by a single human misstep. Yet, it also proves that nature holds the power to heal if we listen and act with precision. The battle between the red crabs, the yellow crazy ants, and the parasitic wasp army continues silently in the undergrowth. No one knows whether the ants hiding in the deep forest will one day rise again, stronger. It remains to be seen if these tiny ecological machines will be enough to keep the balance intact in the long run. Every decision made today will shape the future of an ecosystem over 100 million years in the making.